We're asked here to determine the molecular dipole of these two compounds. We know that carbon and oxygen do not share their electrons evenly. So these are polar bonds. Where the carbons have a partial positive charge and the oxygen a partial negative charge. And you might think that the way I've drawn it there, that these two dipoles would cancel each other out. But this is not true because the geometry around this oxygen, the electronic geometry is tetrahedral. It's got two lone pairs on it. So the electrons, we get two, and we get a bent shape. Because of the bent shape, we get a dipole that looks something like this. If we look over here at the carbon dioxide, again, we have polar bonds, but in this case, the electronic configuration and the molecular configuration or shape of the molecule is linear, and therefore these two dipoles will cancel each other out, and there is no molecular dipole. So when you consider whether something is going to have a molecular dipole, you need to consider first whether it has a difference in electronegativity among its atoms, and then you need to consider the shape. Both are important.